So, hi everybody and welcome back to this C++ tutorial series for absolute beginners. This is video 114 and in this video we are talking about a new keyword. The keyword is static. So, this static keyword has different use places and we will talk only about static in combination with variables in this video. So, that means I click this one here and then it jumps here to the variable section. But before we talk about the variables, let's go on top and see here this line here because it describes what this static is. I read it, the storage class specifier. And yeah, the storage, we have not talked about it. This is also a very theoretical thing. What I mean with that is this kind of words you have to watch online or on C++ books. We can't do all the theoretical part in this practical videos because these videos are more intended for practical use. We try just to find the thumb rules where we can work fast and not all time absolute accurate, but the program will work absolute perfect. That's our goal. But if you want to understand the backgrounds, you have to dive into theory, which means you have to find a good C++ book, online documentations, and ask online in forums and so on. That said, let's continue. So the static keyword here, it says here the storage class specifier are part of the name. This decal specifier sequence means just it starts with the name, declaration, specifier, sequence. And then, yeah, here it says again of a name declaration syntax. All right, that is it. So in our case, we will see it in front. And then it says here, this is important, together with the scope. Okay, the scope, we will talk about the scope a lot with this static of the name. They control two independent properties of the name, and that is this here. We will talk only a little bit about this one, storage duration. Again, this theoretical thing we have to talk. Storage duration and linkage. This kind of words you have to really read in theory because this is not easy explained to. Let's say I could explain this on videos, but that will take too long. That's why we just go to the point what we are interested in our practical use, and I jump to in this case, for example, I will explain a little bit about the storage duration and linkage, not all. I jump to the storage duration, and the storage duration is here. We are only interested in this two actually right now. The other ones we skip. There is an automatic storage duration and there is the static storage duration. And the static storage duration is the thing what we learned today with the word static. And this other thing what we have here, automatic storage duration. Oops. Sorry. This other automatic storage duration we have already learned, but not this word automatic storage duration. I have never mentioned it. And we will talk about this and this. And we will talk also a little bit about linkage. But only this two thing here, no linkage and internal linkage. And again, in combination with static. Static is probably here in internal linkage, which is this line here. And we will talk then about, again, a little bit about no linkage, which we already know. I have not mentioned it. We have not really talked about linkage and so on, because like I said, you have to read this in theory, but at least you start to see these words here, no linkage, internal linkage, and so on. Okay, that's the way we go. Let's start. And before we start, let me show you one more thing. In our exercise, I said I found on the web an attempt for generating password. That was this code here, which I showed you here. It started here. That was not my code. That was anyone on the web created this one. And then he generated these two functions. And here, interesting is this function here. He used here this static word. And We will talk about this one later too, after we learned this one, and see if we understand this, why he's using his static, and what I did to solve this other way around. So with that said, let's uncomment this one here first. We uncomment this one, comment this one, and we start from scratch with int main. And I say, okay, oops, main. And then I say, all right. First of all, I said we talk about static variables, right? So we have to learn first to create a static variables, how we create a static variable. So let's create a static variable. But before I create a static variable, because I know I need a function soon too, let's create a function here as well. And I call this function void, and this time on top, void, the definition one. And I call this function void count my numbers. Count my numbers. And like the function name, it gives us a hint what I want to do. I want count anyhow my numbers. I make it very simple. I say now you should count, well, not my numbers, count numbers. Just count numbers. So, and this void function is very simple. It will just count numbers. It will increment all by 1. All right, so far so good. And now, the interesting thing is now I will use a static function, and not function, sorry, static variable, or I can choose a non-static variable. A non-static variable is that what we all time use. Let's start with our non-static variable, which we use all time, which is int my number. All right. And then I assign a start value for it. Okay, my start value is 0. All right. And now what I want to do is I want to increment this number, right? We know this all right. And then my number. And we know the shortcut when we make this plus plus. This is the shortcut for my number plus 1. And then assign it back to my number. We know this. We learned this. Perfect. And now this is all what we know. We go down to the main and we call this here. Let's copy this one here. Yeah, copy, paste. And yeah, I call it here. And now when I run this one, and I will see that what we all know, right? It will see actually nothing because I forget something. I should also print this out so that I can see something. And we use stdc out, what we all time use, and here my number. Nice to go. So till now we are really good. I make it so that, yeah, it is 1. We increment it 1 time. And of course I could make here a while loop, for loop, but I'm really lazy. Instead of typing all this one, I type it 4 times, so 5 times here with copy paste. Okay, that you should not do something like that. Of course, you should use here a while loop, for loop, also. But with that one, I skip this all. You see, you should not do this, but sometimes you can do this because a while loop or for loop is more or less doing the same thing what I did here behind the scene, right? This is similar. Okay, let's continue when I start again the program now with different calls, and you see it is all time 1 1 1 1 1. And the reason why it's all time 1 1 1 because we learned this one is calling this function. This function will create this variable here because this one is a variable initialization, right? A declaration and initialization and all things together. Because here I declare a variable, here I assign a value to it, here I increment the variable, and here I put out this variable. And all time when the function goes to the next function call here, it comes again, it creates this variable new. This variable is used here to increment. This variable is used here to put out. And here one more thing which I have forgotten to say. This variable which you created here is in local scope. We learned this also. This thing here, this curly brackets are indicating scope. Scope means you are only visible here and this visible means if you declare or create a variable here, after this scope ends, which means here I start, here I end, I will destroy this variable behind the scene, right? That is what I have never mentioned till now so much, but perhaps you already know this if you read the documentation, which I said this is a practical use. You should read all things what I explain here again in a better C++ book where all is more defined in. And here it's a little bit important. That's why I explain it here a little bit again, but not too perfect, but it's right. So, all right, we have this scope here. This variable is created here. After this variable reached the scope, this variable is destroyed. And then that was for the first count here. Then the next count call goes again here in. Then here the scope starts again. The scope create this variable, use this variable to increment it by 1, use this variable to put it out, and then it destroys the variable so that all time the variable starts from 0, right? That's why it's all time 1, 1, 1, because this variable is all time created from scratch, all time new again, and with the value 0. And now I'm going to change that. Now I say I use a static. Let's see what happens if I use this static keyword. And the static keyword you put in front, because this is the indicator. You say static, and then all the other things are the same. You say this whole thing here is now static. And okay, well, when I started this program before, all was 1, 1, 1, right? And now let's see what happens with this static. I start this program. Wait a minute, what happens? 1, 2, 3, 4, 5. And right now I explained to you that this scope here, right? This scope here is destroying this variable. And that is not the case with the static int. This static says, let's go through this a little bit. Let's say here the counter calls this variable. Then it jumps to the scope. The scopes will try to destroy this later, right? So after you started this variable, used it, and used it here to put out, I will try to destroy this variable here, which was before. But the static keyword says, no, you are not destroying this variable anymore. This static means now this variable here, which is indicated with static, will stay all time till this program, at least till the CPP file here, it's called a translation unit. When you read here one CPP, that's very important. Not all CPPs, perhaps you have here more, but this one CPP, from top till bottom, it's called a translation unit. And this is again a word which you have to read in theory, but think about it, it is just the thing here, it is just a special word, and it means just this file here. And this static word says, as long when you use static in front of a variable, this variable is now all time active till this unit is finished, which means in the end effect, this main starts here, main stops here, and then this static unit will be destroyed here at this end here on the bottom. And let's see if this is true. So when I start here the count, it goes here in the scope, it goes here and creates this one here, because this one is still a creation, right? A variable declaration. And here it assigns 0. Then it goes here, it increments this one plus 1. And then it puts this out, and then it comes here and it says stop. I want to destroy all the variables. For example, I want to destroy you. Oh, you have this key. You have this static in front of you, which means okay, I can't destroy you. So that means this one will jump back to this place. It will go here, and let's see what happens now. That's interesting, because now we make here a second call, right? So the second call goes again here. It starts again the scope, and here, that is interesting now. It finds again a static int my number. So what you normally would think is it will declare, like it shows here, a new variable which is called my number, which is then 0, and that is not happening because the static word says, I know this variable declaration already. I have stored it behind the scene. So the compiler will see, oh, this one is static and this was already declared before I come here, which means the second call will not declare this again because the compiler knows I declared it already here at the start when I come to this point. And that means the compiler said, okay, you are already declared. Then I use the already declared version from before, behind the scene. And that's a little bit tricky because it's all time. I call it behind the scene because that's how the compiler make it not visible here in front of us. But behind the scene, it says, I have this value, and this value has already the value 1. So it was not, so it says not only this was declared before, it says this was declared and it was assigned a value 0, and this 0 was incremented by 1, and this, yeah, that was outputted, but more important is it was incremented by 1, and this new value is stored to this variable behind the scene, and the second call here will use now this variable which was incremented. So now when I start this one, this kind of stuff, what you see here, this 1, 2, 3, 4, 5 makes sense because the static says, let's follow this a little bit again. First time, the first call, it comes here, it creates it the first time. So the compiler knows it not at the start. The compiler sees it the first time, okay, I declare it, I assign it the value 0, and then I see also static, which means it should be available in the whole file here in the translation unit. I make it now, I save it behind the scene in the whole translation unit. And till this file stops, I will be available. I make it available for you. And then it says, okay, in the second line here, it says, okay, we increment this value was 0 with 1. Okay. And then I put this out, and then in the second call, you can see what happens. The compiler goes here, use the second call, it jumps again to this count number, and it says the static int my number, and the compiler says, oh wait, I already have you in my, let's say in my storage in my brain. I know you, I already declared you, and I know also that I have incremented you, which because the increment value was 1. The new value which was assigned, and then it say, okay, here you are 1, then I use this value, my name here, increment it, and it becomes 2, and so on. And yeah, this is so more or less the function of static. So we as a programmer have just to know this one will be saved behind the scene and used again. And we have not to make the mistake that this one will be declared again, right? So a normal variable like the without static will all time destroyed here at the end. This one will destroy it here at the end of the scope. So when you call it here again, this one, this one will create it again. The second one goes here top and create this all time new. That's why it starts all time with the 0. But if you make the static, this one will behind the scene, the compiler will save this behind the, let's call it save this behind the scene, we know it, and then it will available during the complete file here, which is the translation unit. All right, so I hope it makes a little bit sense, but of course we have to go a little bit, and let me explain here, not all words, but let's say the two things here. Only these two words here, these two sentences here, not much, all other we skip. So the static storage duration here is exactly that what I mean with the compiler saved this one behind the scene and he remembers it. And when you call it again, this one is static storage duration. In this case, it means it is whole available in this file here, CPP, the translation unit. It will be available till you are going here out of main, and then if main ends, all will be destroyed, then this one is also destroyed. All right, so let's go here back. Of course, you should read this in the documentation a little bit more better if you find a very good C++ book. Let's go to this here, back to this automatic storage duration. This one, we already know what this is. I have never mentioned it, but now I mention it. This automatic storage duration is the other one. This what we already used till now, this normal variable declaration. Why it is called automatic storage duration? Because the function here, for example, calls it here. It has here the scope, and it creates in this scope. It used in this scope. It used here again in this scope to print out, but here it destroys it. That is all time based on the scope. This automatic storage duration means it is not available in the complete file here, right? This one, this value here, you have not available later, which means after you go out of this scope here, bang, this value is gone and it will be declared from start. That's why it's called here, again, this is not the perfect definition, but this is the easiest way to think. Automatic storage duration is the thing which we know already. All time this declared variables in if the local scope, something like that. And yeah, I will not go over the other ones. You can read them a little bit. And I want to go here to this linkage perhaps a little bit. Yes, and this linkage, what I mean was actually this, this translation unit here. It says here, internal linkage. The name can be referred to from all scopes in the current location, and that is exactly the static, not this one. This one has not internal linkage. This one has no linkage. We will see what this means in a moment. But when I write here static, this means internal linkage, and that was more this translation unit, which means I can refer it from all places. That is this kind here, and this no linkage here is again that what we already know. That is this other what we already made here, this without static. This is no linkage, and no linkage means here it is only valid at this scope here. So because you can only use this here in this little scope, this and when you make, yeah, you have to read this one a little bit. Like I said, it's a little bit, you can explain this here on videos, but that will take forever because it's a little bit more theory than here practically use. But we as a practical, we have just to think one thing. We will try to think very simple, very fast, because we don't want to think too much about these keywords here. We want to concentrate on our task, which is to program and make our task, finish our task. So let's write here static, and let's find here a fast rule. When you see just static, you have to know that this variable is saved behind the scene and this one is not destroyed. That's enough. If you know this one and if you use it again, then yeah, you have keep this in mind, that this value is not destroyed like the other ones here. For example, all other variables would be destroyed, but this static value is not destroyed. And so I think let's jump fast here down to the example again of this. Let's comment this one out fast. Let's go to this code example what I found on the web and see the problem here. So here he used this. Here I showed you can use this one here. And you see, he used here something like static unsigned int string length, right? Let's try to understand what this code snippet was made for, right? So he called it in a function. We have here scope, but careful, we have here another scope, and which means this one is a scope. That's why I said make all time these curly braces and not the shortcuts, because in C++ there is also a shortcut where you can sometimes skip these curly braces. We are not skipping them because we want to see the scopes and so. And that's why we jump here, and here it says static. And let's use this information what we learned so far. What means this? When the compiler jumps here to the function, it jumps here to this scope, first to its own scope. This is the function scope, but here is another scope, which is the while scope. And the compiler goes here, and then it creates it first time. So when it creates this variable, which is called here string length, the first time, and here, I hope you know what unsigned means. Unsigned means just without any sign before. For example, integer are signed by default, and if you write unsigned, which means you can only use the positive one, so that is just this one, so nothing special. And then you use here the static, which we learned right now, which means you declare it the first time the compiler will save this variable behind the scene. And when you call this crack here again anyhow, right? If you call this function again and the compiler goes again here, it goes here, and it comes here at this one, it will not create this one again. It will just use that what it is created, which the variable he has right now, and then go on. And you can see here this generate here. Let's jump to the generate here. Is look what happens here. The generate is calling, it changing the length here. And then it does this append, which we have discussed in our exercise. And interesting is it calls, let's see what happens. It calls this, and yeah, this one will be later returned anyhow. And so which means is this function here will go back here to this point, because this is a while loop. Any time this function will stop, right? And then the string length will increase, and then it goes back to this while loop, and this while loop is all time true because it is a infinitive loop at this point, at least. And then it will definitely jump here again, but when it jumps here, it will use this one. And interesting is this string length here is changed here in this function generate string length. Let's go here again, generate. It takes here, and you can see the string length recursively changed here. And this change here is actually changing this one here on top, right? And this one is then changed. Even so, and important is not that it is changed. Important is that when this function while, let's say it jumps, this while comes back again after all this finished again, it jumps here, and make not the mistake that it is created again. When you see static, it will be created only one time. When it comes back, like in this while loop, it will come back again. It jumps here. It will use the saved string length behind the scene. So that's that. That was unclear in our exercise a little bit. I said, okay, use the static. First I said here, I think, use the static function. And later I said, okay, we have not discussed the static, how we can avoid static. That was also interesting. I wasted there too much time. And there was actually a very easy solution. How we can avoid this one here. That it is used again and again. And my solution was very simple. I said, later it was simple. Instead of using this here, I said put this variable without static in global namespace, which means it's on top. And global namespace has all time access, then you don't need static, because the global namespace means if this one is changed in the function, it will change in the global namespace, and then you can call it wherever you want and it is changed. But that was just a solution. I don't know which one is better. You can keep this one, perhaps this one here, because it's safe behind the scene. So I talked much. I hope you understand static. There are different kind of statics, by the way, very important information. There are function statics, there are class statics, and they have a little bit different behavior, but not too much different. But when you see static means it will probably save behind the scene. So and it will be not destroyed and in the translation unit. Most time it will, in variables, will be not destroyed. The translation unit is the code, and this CPP file where you were careful, if you have more than one CPP file, that is not the translation unit. The translation unit is only the CPP file where you're working, because the compiler is only compiling first this CPP file, and there we will learn also this external linkage and something like that, and then you will see the other one can be included as well. Depends. Yeah, and don't confuse this one later with class and functions. They have a little bit different behavior. So I hope you understand static a little bit and read a little bit if you want, because static will come a lot in programming, because many use static to get fast access later, or they don't want all time create like this here. They want not put it in global space, so they want have this one as a local solution, for example, for one reason that can be important, and so on. All right, with that said, like all time, if you have questions or any complaints, write it in the comments, and see you in the next video. Bye.